x to the 10. Now, what if I do this? Two bases, two exponents. What am I going to do with them? Still add them. So I'm going to get x to the 4 plus 3x plus 7. And I get x to the what? 3x plus 11. All right. Those are with variables. What if I give you this? Same story. So what do we get down here? A 2. We don't get 4, right? We didn't get x squared. Base 2, base 2. We keep 2. And then what do we do with the exponents? Add them. So we're going to get 4x plus 4. Exactly. Okay, what happens if I do this? Can I put them together? They're not the same base. Can I make one of them be the base of the other? You're always going to make them be smaller, not bigger. So I'm going to make 4 be base 2. 2 to what power is 4? 2 to the 2. So I can rewrite this as 2 to the x times, and 4 would be 2 to the 2 x minus 3. And I put the x minus 3 in brackets because everyone forgets to distribute to both of them. So I still can't put them together yet, right? I have to distribute that 2 through. So I'm going to get 2 to the x times 2 to the 2x minus 6. Now can I put them together? Now they're the same base, so I can add them. So I'm going to get 2 to the 3x minus 6. Okay, what if I do 3 to the x plus 2 times 9 to the x minus 4? 3 to the 2. So I can make the 9 be 3 squared, because currently I can't put it together. I'm not going to square the 3. I always make the bigger one smaller, okay? So I'm going to get 3 to the x plus 2 times 3 to the 2. And then I put x minus 4 in brackets. And the reason why I do that is I know common error is to put the 2 with the x, but to forget to put the 2 with the negative 4. Do you see that, how it has to go into both? People forget to put it there. And that error will be an answer on the diploma. You forgetting to distribute that 2 through will be an error. So we get 3 to the x plus 2 times 3 to the 2x minus 8. And I should have equal signs running down this side. And what do I do with the exponents? Add them. So I can go 3, and if I want to show the work, I can. X plus 2 plus 2x minus 8. So I get 3 to the x plus x is 3x. 2 minus 8, negative 6. Just leave that. Okay, so I can make the 3 be 9, I can make the 9 be 3, the 4 be 2. What if I give you this, though? 4 to the x plus 1 times 32 to the x minus 4. Anyone have any ideas what bases I could make them be? Because I can't make 32 be 4. Yeah, you can make them both be base 2. 4 is 2 to the what? 2 to the 2. And then we're left with x plus 1. And 32 is 2 to the what? Nope. 2 to the something. 2 to the 2 is 4. 2 to the 3 is 8. 2 to the 4 is 16. 2 to the 5 is 32. Then we distribute both of them. So we're going to get 2 to the 2x plus 2 times 2 to the 5x minus 20. Same base, add exponents. So I can get 2 to the 2x plus 2 plus 5x minus 20. So it equals 2 to the 7x minus 18. Yeah? All right. You're going to try this one on your own. We've talked about these ones already. I want you to turn these into the base they are. So if I want this as base 3, what's 9 going to become? 3 to the 2, yeah. So we're going to get 3 to the 2 to the 2x. And that becomes 3 to the what? 4x. So we have one base and the exponents touching, you multiply, right? 125 is base 5. What base could it be? Base 5, 5 to the what? 5 to the 3. And if you don't know, go 5 squared, 5 cubed, 5 to the 4, 5 to the 5, right? So you get the match thing. So 125 is 5 cubed. And then that's to the 2 minus x, which I made sure to have in brackets. So I distribute through. So I get 5 to the 6 minus 3x. 8 and 16, do you see those side by side multiplied? You cannot write that as 8 times 16 to the x. Like you can't put those together. This 16 is to an x. A whole bunch of people will give me that as an answer all to the x. You can't. Because this one has an exponent on it. The only way you can put them together is if they're the same base. So it says to make them base 2. So 8 is 2 to the what? 2 to the 3. And 16 is 2 to the what? 2 to the 4 times x. So do you see how since that 16 has a variable exponent on it, you cannot put the 8 and the 16 together. We can put them together if we make them the same base. So we get 2 to the 3 times 2 to the 4x. And what do you do when you have the same base? Add them together. So we get 2 to the 3 plus 4x or 4x plus 3. It doesn't matter the order. So you have that. Do you think they'll have the answer 2 to the 12x there? Multiplying them instead of adding? Absolutely. So the other thing we learned in grade 10 is you can take this 512 to the 3x and you can bring it up by making this 3x negative. So I can rewrite this as 512 to the negative 3x. Now, side note, in your calculator, please everyone do this. Do 1 over 4. What is that? A quarter, 0.25, correct? This 4 is to a 1, yes? So if I brought this whole thing up, how else could I rewrite this? 4 to the, move this up, this positive 1 is going to become a negative 1. Type that in, 4 to the power of negative 1. 0.25, right? So you can move those exponents up, you just have to change the sign. So if this was a negative 1 down here, when I bring it up, it would be a positive 1. Okay? So now that I brought this one up and made it a negative 3x, I have to make it be base 2. 512 is 2 to the what? 9. Is it 8 or 9?
It's 9.
It's 9? So we get 2 to the negative 27x. 9 times 3. When you have one base and the exponents are side by side, you multiply them. When you have two bases, two exponents, you add them. So when they're attached by like a bracket, that just means multiplication. Okay, 16 and 81. We're not going to split them up. We want to make them be 2 over 3. 2 to the what is 16? 2 to the 4 is 16. What about 3 to the 4? Can you put that in your calculator? What's 3 to the 4? 81. So 2 to the 4 and 3 to the 4 are 16 over 81, correct? Mm-hmm. So I can just write that as 2 over 3 all to the 4. And then what? X plus 5, and you have to remember to distribute through, right? So we get 2 over 3 to the 4x plus 20. This says your turn. So your turn. Go. Quickly. Base 2, this would be 2 to the 5 to the x equals 2 to the 5x. 1,000 is 10 to the 3, 2x plus 1, which you have to remember to distribute through. So you get 10 to the 6x plus 3. 81 is 3 to the 4, x minus 2. So you get 3 to the 4x minus 8. Move this up, so I get 64 to the negative 2x, which is 4 to the 6. 4 to the 6, 4 to the 3. I want to do 2 to the 6, sorry, in my head. 4 to the 3, the negative 2x, which equals 4 to the negative 6x. Next page. Quiet, please. This one everyone gets wrong. It's 2 to the 1 times 2 to the 2x, which actually equals 2 to the 2x plus 1, which a lot of people just have 2 to the 2x. Remember, your 2 is to a 1, and you need to put that 1 exponent up there. 9 is 3 squared times 3 to the 3, x minus 3 when you distribute the 3 through. So you get 3 to the 3x minus 1. And then this one you take base 4, this is a 1, this is a 1, so this would be 4 to the negative 1 times 16 to the negative 1 to the 4x minus 4. So this would be 4 to the negative 1, and then 16 would change to 4 to the negative 2. If you ever want exponents to pop up, you just make it to the negative. And then 4x minus 4. So we get 4 to the negative 1 times 4 to the negative 8 plus 2x, which equals 4 to the 2x minus 9.